Operation of RNN. Let's talk about the operation of the RNN model. We saw the diagram of the RNN model, but we still don't know how RNN model operates. What is the basic operation of the RNN model? Let me show you graphically here. Look, this is my input layer, this is my hidden layer, this is the output layer. Input layer, hidden layer, output layer. Suppose this is my x sub 2, this is my y sub 2, which is the output. This is my x sub 3, this is my y sub 3. Now there is output coming out from the x sub 1. Suppose on the other hand we have x sub 1. So the output coming out of the node in the hidden layer is x sub 1. This output is x sub 1 here. It goes as an input to this hidden layer with a weight. Don't forget we have weight. The weight of the x sub 2 is w sub x sub 2. And then there is a summation process with the activation function. Don't forget it. We use activation function at two places, in the output layer and in the hidden layer. So here the activation function and the summation process takes place, and then the output going out from this node of the hidden layer, from this node. One to the final output layer here, which is y sub 2, with the weight w sub y sub 2, and the output is x sub 2. The other is going to the next node of the hidden layer, the second node, which is the node for the x sub 3. So the x sub 2, this x sub 2 is the output of this node. It is going here to the y sub 2 and also to this node with a weight. Don't forget we have weight. Now when you look to this, it is the output coming out of the node from x sub 1, but it behaves as an input to this hidden layer. Similarly, the output going out from this node behaves as an input. It is actually the output. It is actually the output of this node, but it behaves as an input. It goes as an input to the final output layer. Similarly, it behaves as an input. It is actually the output. It is actually the same output which is going to this y sub 2. It is the same output coming out of this node, but basically it behaves as an input to this node. Here my x sub 3 has weight w x sub 3. Now the output going out from this node of x sub 3 input, one to the output layer which is y sub 3 and the other to the node of the hidden layer. So this output coming from one hidden layer, second hidden layer, third hidden layer, and then it goes to the fourth hidden layer, and then the fifth, sixth, 7, 8. But actually the output coming out of this node behaves as an input to this y sub 3, and also it behaves as an input to the other node of the hidden layer. So all the time we have this output with a weight, output with a weight, output with a weight, and also weight, output with a weight, weight. So we have all this reconnection between the nodes of the hidden layer. Remember, we do reconnection in the hidden layer, not in the output layer, not in the input layer, in the hidden layer. Mathematically, I can write x sub 2 equals to summation or f of weight times x sub 1 plus w sub x2 plus w sub x2 times x sub 2 plus b sub x, where y sub 2 equals to w sub y2 times x sub 2. And then x sub 3 equals to summation over f of weight times x sub 2 plus w sub x3 times x sub 3 plus b sub x, where y sub 3 equals to w sub y3 times x sub 3. Look, this is the mathematical expression of this RNN model operation. Here is the mathematics behind the scene. This is the technical part of the RNN. So logically what is going inside the RNN model is exactly happening here. It is logically what is going inside the RNN model. When you look to the x sub 2 input, here we have summation with the activation function of, so we have w times x sub 1 plus w sub x sub 2 times x sub 2 plus b sub x. So this operation coming from the left side, it is coming from the left side, weight times x sub 1, which is actually the output coming out from the x sub 1 node. Remember, there is another node on the left side. So it is the output coming out of that node, that hidden node. It is x sub 1 times weight plus w sub x sub 2, which is the weight of the x sub 2 times weight. It is the input x sub 2 times with the weight plus b sub x. B sub x is actually the bias value in this node. But what about the y sub 2? Y sub 2 equals to W sub y sub 2 times x sub 2. Remember, this W y sub 2 is this white weight. It is the weight of this output here, which is x sub 2. It is the output coming out of this node. Don't forget, for all the outputs which actually behave as an input for the another node has weight. We have weight for here, x sub 1 has weight, x sub 2 has weight here. This output also has weight. Here we have weight. This x sub 1, x sub 2, x sub 3 are the output actually of the nodes from the hidden layer. But basically they behave as an input to the next node. They must have weight plus the bias value here. So y sub 2 equals to W sub y sub 2 times x sub 2. Similarly, when you look to this part, we have x sub 3 equals to summation with the activation function. It is not summation over f. It is not sigma over f. Don't forget, this is not sigma over f. It is just showing both summation and activation function. I repeat it. It is not sigma over f. I'm just showing you that it is summation and activation function. So x sub 3 equals to summation with activation function of weight W times x sub 2, which is the output of this node, plus W sub x sub 3, which is the output of this x sub 3, times x sub 3, this x sub 3, plus bias value, which is B sub x. Bias value is the B sub x. So we have the same B sub x. Why we put again the B sub x? Because remember, we are dealing with the one hidden layer. We have only one hidden layer. If there is a second hidden layer, then it might be C sub x. If there is a fourth hidden layer, there might be D sub x. But this B sub x means that this bias value is different here. This one is different. They are not the same. They are different. You can say that it is B sub 1 and this is my B sub 2. Since we are dealing with one hidden layer, therefore both of the bias values belong to the same B class. Therefore I gave B to both of the bias values. In fact, actually they are different. They are not the same. Similarly, y sub 3 equals to W sub y sub 3 into x sub 3. This weight times x sub 3. This is for the output node. So here is a mathematic. Look, this pink weight is the weight. It is the same weight coming all the way during the reconnection. It is coming from the reconnection. So we have the same weight. It is the weight from the reconnection. We have W here, W here, W here. So the same weight is going for all the reconnection. But don't forget with a different output here, x sub 1, x sub 2, x sub 3. Similarly for x sub 4, if there is x sub 4, there will be summation with activation function of W times x sub 3 plus Wx sub 4 times x sub 4 plus B sub x. You can go further and add more input and output layer like x sub 4, x sub 5, x sub 5. You can go further on the right side. You can add more layers like x sub 4, y sub 4, x sub 5, y sub 5, x sub 6, y sub 6, and so on. So I hope it is clear now that how RNN model operates. What is the operation? What is the logic behind the scene? What is the mathematics behind the scene? So I hope it is clear now.